All right, I'm going to go ahead and record this lesson so you guys can have an idea of how to work on this. It's being recorded already. Question? I will post this on YouTube, yes. And I'm going to do the first two with you guys, and after that, I'll release you guys to work on this with your group, okay? This will be a collaborative study. I will go around tutoring each one of you guys' tables as we work on this together, okay? So I want you guys to do as I do for the first one. First off, go ahead and put your name at the top. Yeah, go ahead.
Put on a number?
Yeah, you can. All right, directions. Set up with basic percent problems. Sometimes you will have to do extra steps to solve the problem. Follow rounding directions, answers, and solutions start on page 6. So the first one says a student earned a grade of 80% on a math test that had 20 problems. How many problems on this test did the student answer correctly? Before anything else, ladies and gentlemen, what I want to do is I want to set up a go-to formula that's going to work every single time when I work on percentages. Okay? I'm not even going to think about anything else other than setting this up. And I want you guys to draw exactly what I'm drawing. A line equals a line over 100%. And then under the 100%, I want you to write the word total. Because what is the maximum total points you can get on an exam?
100.
Right. It doesn't matter where. That's the total amount that you can always get. It's 100%. Why do you think the emojis are created with the 100%? Have you guys seen that? That like always giving 100. You know, that's basically it's the phrase. You're always giving it your all. That's when people say like, I'm gonna give 110%. How is that possible when you can only give 100?
Yeah.
But it's just a figure of speech. It's a way of saying like I'm gonna go above and beyond what I'm normally supposed to do. Next to this total, I want you to write total right here, not under the line, because what you're going to put right here is a number, and up here another number, and right here another number. So I set this up as a guide. Welcome back, sir. Just to let you know, we are recording the lesson right now, so everything can be heard. I'm going to go ahead and reread the question one more time. As it says, a student earned a grade of 80% on a math test that had 20 problems. How many total problems did my exam have?
20.
Is there a specific space I can put that in here?
Yes.
I'm going to put it right here where it says 20. Because that's the total amount of questions. Does the problem tell me anything else? As far as it gives me two numbers, and I already crossed out, I already have the 20 problems taken care of. Does the problem say anything else in there that I could possibly fill in somewhere else? Eddie? 80%. I'm going to go ahead and put the 80% up here and cross this out. How many problems on the test did the student answer correctly? Do I know how many problems he answered correctly?
No.
I'm going to put N right here for number. Because I don't know what he answered. But I want to put something to represent the unknown. And get used to this, because when we move on to algebraic expressions towards the end of February and March, that's when this will kick in. So I have my problem set up. I'm going to use what's known as the butterfly method. And multiply, or basically cross multiply. You can do that too. Either one works. And I'm going to multiply 80 times 20. I know that 0 times 0 is 0. 0 times 8 is 0. Or cross that out. Add a 0 here to line up the place values. 2 times 0 is 0. And 2 times 8 is 16. So I'm going to write 1,600 up here. And then 100 times n on the bottom. I'm going to put 100n. Because 100 times nothing is nothing. But I have a letter representing the unknown problems for the how many problems on this test. Next, I'm going to divide 100 by 1,600. I'm going to ask myself, can 100 go into 1? No. Can 100 go into 16?
No.
No, it can't. Can 100 go into 160?
Yes.
Yes. So I'm going to go ahead and subtract or add the 1. So 1 times 100 and subtract 100 from 160. 0 times 0 is 0. 6 times 0, I'm sorry, 6 minus 0 is 6. I should have actually said earlier, 0 minus 0 is 0. 6 minus 0 is 6. And 1 minus 1 is 0. It means nothing. I'm going to leave it there. I'm going to break down this extra 0 I have right here because it's part of the 1600. And I'm going to ask myself again, does 100 go into 600 now?
Yes.
How many times?
6.
And I'm going to subtract 600. I can technically write 16 over here on the top. 16 over 20 is the same thing as 80 over 100. That's what you need to understand. So the question is asking how many problems on this test did the student answer correctly? I'm going to respond in a complete sentence saying, the student answered 16 questions correctly, period. I can circle 16, I can circle 16 here, and I can circle my sentence answer, so that way, when my grader is looking at this, they know exactly where to find. Can I do one more for you guys?
Yeah.
All right. I'm not even going to read the problem. I'm going to create my little table first. Is that cool?
Yeah.
Because this is kind of like my formula. It's almost like saying, think about your grandmas that know how to make tortillas, and they don't even need the recipe. They just grab all the information they need. They just grab all the ingredients, all the ingredients they need, and they eyeball it, and then bam, 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 and they just know inside what to do. When you set this up, you know inside what to do.
Like when you make a cake.
Yeah, basically like make a cake or a Krabby Patty, whatever you want to say.
Krabby Patty.
Okay, now I'm going to read my problem after I set up my little formula, my little algorithm. There are 36 carpenters in a crew. On a certain day, 29 were present. 1% showed up for work, round to the nearest tenth. Okay, how many total carpenters? Well, actually, let me go ahead and write the word total down here and down here. In a crew, another word for saying group or field of workers, it's like saying crew, right? Like me and my crew. Me and my homies. Me and my squad. That's your total number of friends, isn't it?
Yeah.
How many total people are on this carpenter's crew?
36.
36, right. Don't get fooled. How many people showed up on a certain day?
29.
So I'm going to put the 29 on top of here. Because look at 36 and 29 refer to crew. I'm going to even write it right here. Crew. What don't I know?
How much people showed up?
No, I know 29 people showed up.
Percent?
How much what?
Percent.
Percent. I'm going to go ahead and do that. So see how I have that set up. 36 times n, I'm going to cross multiply, and 29 times 100. Now, I'm going to show you guys a trick because 29 times 100, and that's always going to be the case of always having 100 down here. Can I just get the 29 and add 2 zeros?
Yes.
And does it still mean the same thing?
Yes.
Oh. Can I still divide that by 36n? Because 36 times n is 36n, right? I put them together. That's all multiplication is, putting two numbers together. All right, now I have to divide 36 into 2900. because of time and because of the resources and because I want you guys to focus more on the process, first off, I'm going to use my calculator watch in a minute. But before that, I'm going to just rationalize and understand that 36 does not go into 2, right? Does 36 go into 29? Can 36 go into 290?
Yes.
Okay. So what I'm going to do is go on the calculator, get 290 and divide it by 6. I'm sorry, 36. I'm not getting the whole number. I'm getting 290 first. Divide that. Sorry, my fingers are too big for this thing. Divided by 8.005. However, I'm not going to do that. So then what I want to do is I'm going to get 36 times 7, because that's near. That's 252. Wait. And then what about 36 times 8? 288. So I'm going to go ahead and use that. 8 minus 288. 0 minus 8, is that possible? No, so I'm going to borrow from the 9. 10 minus 8, is that possible?
Yes.
I can't do that. 20. Now I ask myself the question. I bring the 0 down. Can 36 go into 20?
No.
No. So I'm going to add a decimal. And first off, can 36 go into 20?
No.
So I'm going to go ahead and add the 0 right here because I brought the 0 down. I'm going to add a decimal, add a 0, and bring the 0 down. Can 36 go into 200?
Yes.
Okay. He said 6 times. Let's go ahead and try that. 36 times 6.
That's over.
That's over. So let's try 36 times 5
Yeah. 180.
equals 180. So let's go ahead and put decimal right here. 5 minus 180. 200 minus 180 is 20. I add the 0. Well, it looks like I'm going to keep going over and over again. But it's telling me round to the nearest tenth. Let's look at this number. Let me write it down here. 80.5. 5 right here. What place value is this? It's a point. It's 80.5.
The tenth. Tenth. Oh yeah.
Tenths. It starts at tenths. So if this is the tenth and I'm going to round it off, that means I have to look at this number. And here's, do you guys remember rounding around 3rd, 4th, 5th grade?
Yeah.
If it's a number bigger than, if it's 5 or bigger than that, do you go to the next number?
Yes.
If it's 4 or below, do you stay wherever it's at?
Yes.
So because this is 5, I'm going to make this an 81. The answer is 81%. I'm not done yet. I can't just put 81%. I have to write the sentence out. What percent showed up for work? 81% showed up for work. Period. Encircle that.